Rich Durrani with TMC. Thanks for watching. We're at ITEXPO 2014 in Las Vegas, Nevada. Raza with Fiber Mountain is on our show today. Raza, how are you?
Very good. Good to be here.
Pleasure having you. And I figure we would have an opportunity here to talk a little bit about how you've seen networking evolve through your career. I mean, you've had a long, prestigious career through a number of different companies. Why don't you walk us through where have you been and what's happened over your career?
Rich, over the last 20 years, I've had the great opportunity to be in some fantastic companies and at the right time where technologies were evolving. I've been with Fujitsu, 3Com, General Datacom, ADC Telecommunications, TE Connectivity. You know, engineer by degree. I've held some executive positions in these companies, and through the career, I've learned a lot. I've seen a lot. I've met a lot of great people. And today at Fiber Mountain, it was time for us to bring a lot of what we have learned into one company and combine solutions that will really change the infrastructure of a data center.
And you've got some truly revolutionary ideas, but if we can go backwards a little bit, one of the, I guess, constants that we've seen in the networking space, in the data center space, is that there's a need for more processing power, there's a need for more speed, right? That just seems to be a constant, and we have new things like virtualization, but really we're seeing faster and faster connectivity, and we're seeing more powerful computers. And the question there is, how have you seen that change to where we are today, or evolve to where we are today, and how will what you're doing at Fiber Mountain change the paradigm of how networks are built and constructed?
Rich, certainly the processing power and compute power continues to grow, and there seems to be no stop for it. In 2008, I had an opportunity to join ADC Telecommunications, a physical layer company. So most of my career has been on the switching, routing, and telephony side of or the active side of the network. I was fortunate to be at ADC Telecom. I was inventing a technology that was really a physical layer intelligence technology, a technology that identified or uniquely identified every cable in the network. Interestingly, over the career, I've seen that folks that are in the active business, in the networking business, and folks that are in the physical layer or the cable connectivity business just have they're just different businesses, if you will. The people are different, the distribution channels are different, the purchaser at a particular customer is different, deployment cycles are different, just a lot of difference. One of the things that I realized through this journey of my career was if we could bring the switching side and the physical layer connectivity together, there's a tremendous benefit. We will certainly, to your question, continue to increase the processor powers and the compute power. But if we could bring the power of something like a simple fiber optic cable into the picture, what we really end up doing is using a physical layer, a layer 1, which is always in a network. We use that to offload some of the complexity and the congestion that resides in layer 2, 3, and so on. So we're using technologies from layer 1 along with layer 2 and 3, switching and routing, to bring a very holistic network to our customers.
Now, it seems to me that in this new network paradigm, there's going to be less of a need for certain switches. Is that?
That's true. That's true. When you have intelligent, if you will, if the layer 1 has some intelligence and a fiber optic cable or a patch panel is able to communicate with software, much like a switch, it does change the dynamics of the network. You have more intelligence at a lower level. You don't need as many switches, or you don't need as much complexity in the switches and the tables that are built. So we are taking advantage of that, and I think from a career perspective, just having navigated through the switching side of the business and the physical layer side of the business, I was in a very unique position to to bring the two sides together, as well as bring some fantastic people that I've met across my journey into Fiber Mountain.
So what's your vision for the data center of the future?
I see in the arms race, if you will, of growing data centers, I believe that as data center sizes grow, this is certainly driven by our applications, the size of the data center itself really relates to switches and servers and cables and patch panels. We're just adding more and more gear in our network. And when we add this much gear, growth of the network also brings with it an increase in power consumption, increase in heat dissipation, cooling needs, space requirements, and all of those. That's one of the dynamics that we want to change. Allow the network and the bandwidth to grow, but in our opinion, a proportional growth of power and power consumption and heat dissipation is just not sustainable. So what we're doing is focusing on not building the next bigger switch, but really removing switching from the core of the network.
So that's a big change. So I mean, there's some big things happening here, right? Power consumption is I mean, it's a big cost within data centers, right? It's not, power rates are not generally going down anywhere, so that's a macro trend. The equipment within the data center typically is giving off more and more heat. So there has to be some way, if you can, to reduce that heat and reduce that power. And so what you're saying is there's going to be...
we think the best way is to reduce the amount of equipment.
Right. So reducing some of those switches will help, and then using the glass core architecture that you talked about.
Right. Rich, just one point on the previous. Take an example of power. We all want to build greener switches or greener equipment, less power consumption. But that just isn't enough. It just isn't enough. We believe that you need to take some of this equipment out of the network and yet allow the growth in bandwidth. So that's where the big difference comes in.
Excellent. Well, thanks so much for being on the program. This was great.
Thank you very much.